Now we're going to take a look at some other properties of arcs and chords. In particular, chords that are perpendicular to a radius. So one thing that's interesting, if you have, and I have an angle here, so ignore this angle marking. If you have a chord perpendicular to a radius, what does that mean? So I went ahead and connected the point here and here. BC is the chord. And the interesting thing is the type of triangle it creates. Well, okay, if the AB and AC, it creates an isosceles triangle. Well, if it's an isosceles triangle, then you can actually say that angle ABE is congruent to angle AEC. Now, I don't know that these two angles are congruent yet, so I can't really use that. But I do know that the two pieces here are congruent. So it creates the isosceles. Now, how am I going to show that ABE is congruent to ACE? Well, I do know that there's a right angle because we said the chord creates a right angle with the radius. It's perpendicular, which means that's a right angle, there's a right angle, the other one's a right angle. Okay, and I know that this segment is congruent to itself. AE is congruent to AE. Well, that means that this triangle here, if that's a right triangle, there's the hypotenuse, there's the leg. There's the hypotenuse, there's the leg. So these two triangles are congruent by the hypotenuse-leg theorem. Now, what can you then conclude about segment BE and EC? Well, they're going to be congruent. Why is that? Well, if the two triangles are congruent, then these two are congruent by CPCTC, which is corresponding parts of congruent triangles are congruent. So whenever you have chords perpendicular to a radius, it bisects this segment right here. It's a perpendicular the radius is a perpendicular bisector of the chord. Now, that doesn't mean that the chord is cutting the radius in half. It just means the radius is cutting the chord in half. Now, how can you show that triangle EAB is congruent, or angle EAB is congruent to angle EAC, to justify these congruent marks that are sitting up there already? Well, same thing, CPCTC, those are corresponding angles. Not only that, I could actually show it, if that's a right angle and these two angles are congruent, then these two angles have to be congruent. So I could have just shown it by doing a substitution. So what does that imply about arc BD and arc DC? Well, they're going to be congruent because the angles that correspond to them are congruent, then the arcs are congruent. So the conclusion is, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. So BC is bisected and arc BC is bisected. Also, because the chord and the radius create a right triangle, you probably will end up using the Pythagorean theorem to find the missing values. So let's take a look at this example. I have CD is 72 and AC is 65. And I had you find DE. Why did I bother to have you find DE? Because again, we're trying to remember that this radius is bisecting this chord. So DE is just twice that. 2 times 72, or 144. Now, I can actually find the radius here. How can I do that? Well, I can draw a radius here. Aren't the radii congruent all around the circle? So if I find x here, I've found it there. Now, why am I drawing it there instead of just trying to find it right there? Well, as you may recall, this is a special triangle. It's a right triangle. And I know both legs. So that means I can use Pythagorean theorem to find x. So squaring both numbers, adding them together, I get x squared is 9409, or 79. So this radius is 79, which means AB is 79. Which, by the way, means if I wanted to find CB, I could just subtract the 65 from the 79. So I actually know that CB is 14. So some quick notes for reflection. Why is a radius that is perpendicular to a chord also the bisector of the chord? And what prior knowledge could you use in finding missing values when a radius bisects a chord? Hopefully you'll think of our friend the Pythagorean Theorem. Last but not least, our essential question for this lesson. How did we use the properties of triangles and circles to come up with the properties of arcs and chords?